Hello students, welcome back to this new session on mathematics for the subject 18mat31. I am your mathematics teacher from AITM. Okay, in this session I'll be continuing the same topic of Laplace transform of some standard functions. We have already done a few. Now this is the last Laplace transform, and all these Laplace transform of standard functions you will be using in working with the problems. Okay, so I request all the students to take a pen and a paper and start working with me. Okay, this is the Laplace transform of t raised to n, where n is any real number. Let's work for the solution. The solution goes as, okay, we are working for the Laplace transform of t raised to n, that is the Laplace transform of t raised to n. By definition, let us write what is Laplace transform, that is L of t raised to n, that the Laplace transform of t raised to n. By the definition, it is defined to be integration from 0 to infinity e to the power minus st. In place of f of t, you have got t raised to n, so it is t raised to n dt. T raised to n dt. Okay. Now, can you work for this integral like this? Directly, there is no formula as such, but if you can remember, the previous semester I had taught you beta and gamma functions. The definition for gamma function, do you remember what is gamma of n? How is it defined? It is defined to be integration from 0 to infinity e to the power minus x to the power n minus 1 dx. This is the definition for the Laplace, the gamma of n. So the gamma of n is defined to be this way. Okay. In case if I use what is gamma of n plus 1, using the same definition of gamma of n, if I want to write gamma of n plus 1, see here, when it is n over here, you have got n minus 1 as the power of x. This e to the power minus x is, it has nothing to do with it, but and where is n appearing? N is appearing as a power of x, and it is appearing one number less than what is written in the left hand side. It is gamma of n to be represented as integration 0 to infinity e to the power minus x to the power n minus 1 dx. This is the definition of gamma of n. So in place of n, we are now writing n plus 1. So integration 0 to infinity e to the power minus x as it is. In place of n minus 1, x to the power n plus 1 minus 1, it becomes x to the power n dx. These two things I want you all to remember. Okay. In previous semester only you will have learnt it in first semester. So here what I will do to solve this, I have to re-get this thing in this pattern, because I do not want s over here. No doubt the entire definition is in terms of t. Let us convert it in x and represent it as the way. So let us put, to solve this, let us put s into t as some x. So you define your t as x divided by s. And what should be dt? Derivative. Differentiate this with respect to t. Here if you differentiate with respect to t, it will be dt is equal to 1 by s is constant because s is a parameter, and into dx you will get. Okay. Now let us see what happens when x is when t is 0. When t is equal to 0, what happens to your x? X is equal to s into t. When t is 0, x becomes 0. Similarly, when t is infinity, x is also infinity. So using all these definitions, let us substitute back in Laplace transform of t raised to n. So now this Laplace transform of t raised to n takes the value integration from 0 to infinity. I hope it is seen there. 1 minute. Okay. Yes. Integration 0 to infinity e to the power, you are substituting s into t as x, so it becomes minus x over here, into t raised to n. So it is, in place of t you are going to write x divided by s. So x divided by s raised to n, into, in place of dt you are going to write 1 by s dx. So it is dx divided by s. Or you can write completely it as integration from 0 to infinity e to the power minus x to the power n divided by s to the power n into s. So s to the power n plus 1 you get, is it? Into dx. Now this s to the power n plus 1 in the denominator, it has nothing to do with the integral sign here. Get it outside. It is 1 divided by s to the power n plus 1, integration from 0 to infinity e to the power minus x to the power n dx. Now what is this? You see it is here. It is gamma of n plus 1. So this you can replace it as gamma of n plus 1. So this results in gamma of n plus 1 over s to the power n plus 1. Therefore, the Laplace transform of t raised to n, we can obtain it as gamma of n plus 1 divided by s to the power n plus 1. Okay. So this is the complete derivation for the Laplace transform of t raised to n. Apart from this, I had to again tell you one more important point here. What is it? You also know when n is a positive integer, you must know this. What is gamma of n plus 1? I hope you remember it is equal to n factorial. Is it not? It is by this basic property of gamma of n, we can write the same formula, that is the Laplace transform of t raised to n is equal to, in place if n is a positive integer, we know that gamma of n plus 1 is n factorial. By just substituting it, you will get n factorial divided by s to the power n plus 1. So whenever n is a positive integer, you can easily write Laplace transform of t raised to n as n factorial divided by s to the power n plus 1. Whenever n is any real number, then Laplace transform of t raised to n will be this, apart from positive integer. Okay. So this is how we solve for the Laplace transform of t raised to n. I hope it is clear to you. Continue in my next session. Thank you.